Hey, good morning, and welcome to another episode of AI Buzz. My name is Nick, and I have a bunch of machine learning and artificial intelligence related stories for you today. Among them, a release from OpenAI, how machine learning analysis can pick apart key catalytic properties in materials, autoML, how it's becoming scary good, and lastly, how AI can assist in optimizing growing conditions for farming. All that and more on this episode of AI Buzz. Thank you for being here. Let's get started. First up, so I've discussed before how machine learning can do a great job of listening to audio and finding the perfect sample that will fit into a new track, a new segment of your song, out of many. So this application greatly simplifies music production for artists. Companies like Shazam can use machine learning to find similarities between the track that you're identifying and their library of millions of different songs. They can do this very, very fast and very reliably. One of the updates this year from OpenAI won't exactly assist humans in producing songs. It can compose completely new ones. So OpenAI released MuseNet, which can synthesize completely new songs after processing songs in that style. The model from OpenAI relies on a transformer model, and what this does is it allows prediction of the next step in a sequence of steps. So in this case, it's music notes, frequencies. If this type of model is applied to text, then the next step in the sequence would be a word. The model can create 15 different styles already, such as classical or contemporary. So, two of the examples that it brought up in the original post from OpenAI was Mozart and Lady Gaga. The transformer models, as well as GANs, which I've described before about how they can be used in art restoration on this channel, they're truly amazing. These models seem to be creating instead of predicting. What's crazy with most deep learning models is that these models don't understand music in the same way that we humans do. They're purely analyzing the waveforms of the songs. They're looking at this raw, humanless data. It has no soul in it, if you know what I mean. This data, there's no human aspect to it. They're purely analyzing the waveforms of the songs and searching for patterns of different rhythms and styles between the songs. And then when they go to create, they try to find ones, their creation will fit closely within all these different patterns that they've found within that class. So, what does everyone listening think about these models creating original pieces of work? There have been stories about AI generating paragraphs given a topic. This is from OpenAI as well, such as climate change. They've essentially asked their text generator AI, what's a good solution to climate change? And the text generator was able to synthesize a full paragraph response. It wasn't particularly helpful, not very specific, but it's pretty wild that it was able to mostly come up with a coherent response. Another model that was developed was able to finish one of Picasso's outlines that he made underneath one of his very famous art pieces. So he had sketched out a painting on canvas and then abandoned the idea entirely and then painted over it with something else. Through x-rays, researchers were able to find that this was underneath that final painting. They had this outline of one of Picasso's works, and then they tried to complete it with a very similar method. These models are good enough where the creations don't stick out. I think in many cases, if you were to show a non-expert some of these generated art pieces, or even some of these tracks, they wouldn't be able to tell the difference. The gap between the generated pieces and the authentic pieces is going to continue to close. I'm really curious to see how society begins to accept AI-generated work, if they do at all. I suppose we'll find out in the coming years how that all works out. Next up, new story. The climate change problem is apparent to all. Carbon dioxide is being produced at huge rates from automobiles, manufacturing facilities, airplanes. It's a massive problem. It's contributing to global warming. I don't care what you say about climate change being fake. That is not true. Research is being done to curb the amount of carbon dioxide that's being released into the atmosphere and reducing harm that we're causing to the planet. We're not making great progress on this, but some researchers are working on this. One of their approaches is a class of materials called carbon capture materials. So these materials are kind of shifting. They're acknowledging that carbon dioxide is going to be produced from processes necessarily, and they're kind of accepting that fact and then trying to eliminate it. So these materials can actually catalyze reactions, speed up reactions with carbon dioxide, and transform it into a less harmful or a more useful product. Researchers at Brookhaven National Laboratory, they're exploring new catalysts for this process, and they're trying to convert carbon dioxide into methane. So this methane's not a fossil fuel energy source. And in order to understand how well some of these materials might be in catalysis, the research group looked at a bunch of different ones. So the study of the primary investigator of this study is called Anatoly Frankel from Brookhaven, looked at X-ray properties of many different catalysts that can do this reaction. So catalyze carbon dioxide into methane, essentially taking the harmful byproduct of combustion, carbon dioxide, and turning it back into methane, which could actually be reused as a fuel. So of particular interest in finding the best catalyst, the best material that will speed up one of these reactions, is looking at the oxidation state of these different catalysts. So the oxidation state, again, it's key in determining how well it'll catalyze reactions. So copper, in particular, is shown to be really good at being a carbon dioxide catalyst. So it's able to do that transformation from CO2 into methane. So just make a bunch of copper particles, right? Then our climate change problem will be solved. It's much more complicated than that. In theory, it should work really well, but when you try to apply this in the real world, things are much more complicated. It's much more multifaceted. The copper clusters need to be very specific sizes in order to really maximize the conversion of carbon dioxide to methane. Another thing that's very likely to happen is the copper will likely form an oxide in some conditions. And when it forms an oxide, it's essentially useless as a catalyst. So this group, in order to study the likelihood of how copper clusters form oxides instead of staying pure copper, they used a machine learning approach to analyze hundreds of different features and factors about the clusters. So what they did is they had all this X-ray data that contains the facts about the copper's oxidation state, as well as different parameters of the structure. So there's just so many factors to consider when trying to identify the best copper catalyst: geometry, size, all these different things. So they realized machine learning was a great solution here. So in order to create data for this model, they fed it many different models that another group at Brookhaven had developed of different metal clusters. How they're laid out, kind of like 3D structures is my understanding of it, about how everything's bonded together. And then the model, once they crunched all this data into it, the model was able to discern relationships between the different features and the different types of copper clusters. So the end result was you could give this model one of the X-ray spectra, and the program would be able to determine the properties for that copper cluster. So you could essentially, with this new model, in theory, give it an X-ray spectrum that would make it a really good catalyst. So it has whatever oxidation states that you'd like, and then it would output kind of the structural properties of that cluster. So it'll tell you how to make it. So you can compute a spectra that you think it will be really, really good at catalyzing this reaction, and then feed it into the model, and it'll tell you how to make it. The group is working on publishing this work, and this seems like some very important work on kind of the carbon capture class of materials. It's yet another example of how machine learning is being used in science and research. It's really becoming a tool to assist researchers, and I love to see that. Next up, I recently wrote an article about Google's AutoML library. The library allows the users to essentially hand Google their data, and what Google does, it'll then try many different variations of a model and determine which model is the best. So one of the probably more tedious, in my opinion, I enjoy this aspect of data science. One of the more tedious aspects of it is once you have your data ready to feed to the model, is kind of tuning these different learning parameters of the model. So different, if you're working on training a neural network, there's the learning rate. There's probably about 10 or 15 different parameters that you would likely want to, if you're really trying to eke as much performance out of it as you want, as you can, then you'll want to be tuning each of these. So a common approach is to use something called a grid search. A grid search is you lay out for each of those, say, 15 variables, you'll lay out a top and bottom range of what values you'd like to try, and then kind of a spacing in between of those different parameters. And then it creates a grid of different parameter combinations, and then it will try all of them, and then essentially output the one that performed the best in terms of predictive capabilities. AutoML completely automates that. So you'll give it your data, and it'll try to fit a model to it. It'll take care of all of that for you in a completely automated fashion. And what's crazy about that is it will try, so many different combinations of hyperparameters that it ends up performing extremely well. And a human doesn't need to waste all their time and, futzing around with all these different parameters, and it will perform better in the end. So what's wild is that AutoML is good. Really, really good. In a Kaggle competition, a team was actually created for AutoML. It led the competition most of the way, and in the end finished second, which is ridiculous. This win has raised concerns by many about losing the human aspect of AI so soon. So since artificial general intelligence has not been developed yet, humans still need to guide the vast majority of machine learning workflows. And it's still very important to have a human supervising that training process. Not supervising any of the models, especially with something like AutoML, it's extremely dangerous because these tools get used as black boxes with little to no understanding of what it's doing or why. Applying these tools haphazardly could really result in some huge damage. And, in most cases it might work really well. Most industries and most problems, if you can just throw this thing your data set, it'll probably work extremely well. But you run the risk of getting complacent, and when you feed it a data set that confuses it and it outputs something wild, and the humans supervising it just don't even realize that it's a wild prediction. They've relied on this so much that they just think it's going to do the right thing every single time. When that type of prediction and model gets applied out into the real world, you could really run into some big problems. Especially with things like self-driving cars, robots in factories, things like that. So, until we have artificial general intelligence, humans really we need to not get complacent with this technology and continue to understand the underlying processes that's going on with these automated machine learning workflows. Overall, I think it's awesome, but just a word of caution. Yes, we need to keep up with this technology. Next up, I've reported before on how artificial intelligence is being used in the farming and agriculture industries. Not only is it being used during the crop growing phase, so for things like monitoring how well the crop is doing this year by flying drones over an orchard or taking aerial photos of cabbage patches, things like that. It's also being used for optimization and fine-tuning of the growing conditions. A recent study by MIT's Media Lab found that basil plants can be engineered to be grown in the most optimal conditions possible. So the team studied basil plants. They made many important discoveries that would not have been apparent without a machine learning approach. So they actually discovered that basil plants taste the best when they have light every second of the day. This results in the most flavorful basil plants. So 24 hours of light results in the best tasting basil plants, which is a completely that's a lab experiment, as there's no place on Earth that has 24 hours of light per day. The team used a smart farm of sorts, which relied on a combination of sensors, machine learning, feedback loops between the two. It would allow control of all of the different growing conditions, such as temperature, humidity, lighting. And then in order to evaluate the flavor of the basil, they'd actually measure how many volatile components were in the leaves using some lab equipment such as a gas chromatograph. So they tried a big range of different growing conditions, and then they measured how many volatile components were in the resulting leaves. And then what they did is they crunched all that data from all their various plant experiments, and then the outcome, which is that the gas chromatograph results, into a machine learning model. The model then was able to compute outcomes for millions of different growing conditions, and the final output was ranked conditions that would result in the best possible flavor profile. Completely wild. This is awesome. When AI starts, predicting better tasting food, I'm all like, take my money. That is awesome. More flavorful food, potentially better yields. It's going to be optimizing all of these different things about our food, and I cannot wait. The researchers' next step is to hone in on maximizing the disease-fighting properties of basil. I guess there's several. One of the main ones is it has good blood sugar regulation properties. So not only are they going to be maximizing the flavor, they're going to be maximizing exactly some of these really some of these healing properties of the plant. And lastly, MIT open sourced all of their tools for us to use. This is fantastic work from them. Hope to see more about this in the future. That's about all for me today on this episode of AI Buzz. Thanks so much for joining me. I talked about MuseNet. It's a tool from OpenAI that can synthesize original pieces of songs, and they're very, very similar to songs by other artists that it's been fed, such as Mozart or Lady Gaga. Talked about how machine learning can be used to analyze X-ray spectra and find the best catalyst for carbon dioxide conversion. Talked about how AutoML is perhaps too good for us, and we need to stay up to date on how this exactly works. And lastly, talked about how AI is going to be used for both optimizing the growing conditions as well as the flavor profile of certain plants, such as basil, and then how it could also be used to maximize the disease-fighting properties of those plants. Thanks so much for tuning in to this episode of AI Buzz. I'm your host, Nick. I'll be back very, very soon with more AI-related stories. Bye.